Hey all, welcome to lecture 7 of module 4 in database management system. Today we are going to see about the topic properties of relational decompositions. So what do you mean by relational decompositions? So while studying normalization we have seen that in order to normalize a table we used to decompose those table into multiple sub-relations. Okay, for example we are having a table R A B C D. So this A B C D are attributes. So while normalizing, this table may be decomposed into two parts, R1 AB, and the second part will be R2 CD. Okay, so we cannot directly decompose a single relation into multiple relations. In order to decompose this table, a single table into multiple tables or multiple relations, we have to satisfy certain properties or we have to follow certain properties. Okay, so what are those properties? That is what we are going to discuss today. Okay, so decomposition is like this. That is while we are having a relation, that relation can be decomposed into multiple relation. Why we are decomposing it? In order to normalize the given relation. Okay, normalize ചെയ്യാൻ വേണ്ടിയിട്ട് നമുക്ക് വലിയൊരു റിലേഷനെ സബ് റിലേഷനാക്കി നമുക്ക് ചെയ്യാൻ പറ്റും. ഓക്കെ, ആ സബ് റിലേഷനാക്കി ചെയ്യണമെന്നുണ്ടെങ്കിൽ നമുക്ക് എന്ത് ചെയ്യണം? വി ഹാവ് ടു സാറ്റിസ്ഫൈ സർട്ടൺ പ്രോപ്പർട്ടീസ്. ആ പ്രോപ്പർട്ടീസ് നമ്മൾ സാറ്റിസ്ഫൈ ചെയ്യണം. എന്താണ് ആ പ്രോപ്പർട്ടീസ്? അതാണ് ഡിസ്കസ് ചെയ്യാൻ പോകുന്നത്. So actually there are three properties. First we are going to study the first two, attribute preservation property and dependency preservation property. Okay, these two concepts we are going to see today. Clear? So what is properties of relational decomposition? Okay, this is the introduction part. So decompose the universal relation schema R into set of relation schema R1, R2, etc. up to R1, Rm. Okay, so this D is called decomposition of R. Okay, that is we are having a universal relation, okay, called R relation. Universal relation the പേരാണ് R. Okay, this R is decomposed or divided into different sub relation, okay, set of relations schemas which are R1, R2, etc. up to R1, Rn. These set of relation schemas is named as D. Okay, so this D is called decomposition of R. That is what I have explained just now. This is the main relation. This is decomposed into multiple relations. Clear? So this D, this is called D. These are the set of, here we are having two sub-relations. What are they? R1 and R2. Okay, so this R1 and R2 is called D here. Okay, or D, or it is also called decomposition of R. Clear? That is what decomposition means. A relational database schema must possess certain additional properties to ensure good design. Okay, so in order to decompose or to make this decomposition done in a perfect manner, we have to possess certain properties, additional properties to make a good design. What are the properties? We are having three properties: attribute preservation property, dependency preservation property, and non-additive or lossless join property. Okay, these are the three important properties we are going to study today. Okay, among this, the second and the third, that is the dependency preservation property and non-additive or lossless join property, are very important properties. Okay, we used to get numerical problems based on these properties. Okay, so let us see all these properties in detail. First one is attribute preservation property. So what do you mean by attribute preservation property? So when we try to decompose a relation, okay, as I said previously, we are having the relation R A B C D, which is being decomposed into two sub-relations R1 and R2. Okay, so attribute preservation property means that the union or the combination of these sub-attributes, a combination of these sub-relations will be having the same attribute as the main relation. അതായത് ഇതിൻ്റെ യൂണിയൻ എടുക്കുമ്പോൾ നമുക്ക് ഏതൊക്കെ ആട്രിബ്യൂട്ട്സ് വരും? എ ബി ആൻഡ് ഹിയർ ഇറ്റ് ഈസ് സി ഡി. ഓക്കെ, ദിസ് എ ബി സി ഡി മസ്റ്റ് ബി ബിലോങ്ങിങ് ടു ദ മെയിൻ റിലേഷൻ ആർ. Okay, that is called attribute preservation property, which means that when we decompose the main relation into sub relation, the attributes must not be lost. ഓക്കെ, നമ്മുടെ ഇതിനകത്തുള്ള ആട്രിബ്യൂട്ട്സ് ലോസ്റ്റ് ആവാൻ പാടില്ല. ക്ലിയർ? നമ്മൾ എ ബി സി ഡി എന്നുള്ളത് ഈ സബ് ആട്രിബ്യൂട്ട്സിൽ സബ് റിലേഷൻസിൽ എവിടെയെങ്കിലും ഉണ്ടാവണം. ഓക്കെ, ഒരു ആട്രിബ്യൂട്ട്സും ലോസ്റ്റ് ആവാൻ പാടില്ല. ദാറ്റ് ഈസ് കോൾഡ് ആട്രിബ്യൂട്ട് പ്രിസർവേഷൻ പ്രോപ്പർട്ടി. Okay, so when we decompose R into set of sub relation R1, R2, etc. up to Rn. Okay, so when we decompose R is the main relation. When we decompose this R into R1, R2, R3, etc. up to Rn, we make sure that the attributes in R will appear in at least one relation schema Ri in the decomposition, so that no attribute is lost. Okay. That is, we are decomposing the relation R into subrelation R1, R2, R3, etc. up to Rn. Okay, in that case, we make sure that the attribute in R must be available in at least any of these subrelation R1 or R2 or R3. Suppose this R is having the attributes A, B, C. That means this A must be present in at least in R1 or R2 or R3. This B must be present in either R1, R2 or R3. This C also it must be present in either R1, R2 or R3. Okay, അപ്പോൾ ഇതിലുള്ള ആട്രിബ്യൂട്ട്സ് അറ്റ്ലീസ്റ്റ് ഏതെങ്കിലും ഒരു സബ് റിലേഷനിൽ പ്രസൻ്റ് ആയിരിക്കണം. ദാറ്റ് ഈസ് കമ്പൽസറി. ദാറ്റ് മീൻസ് ദാറ്റ് ദ ആട്രിബ്യൂട്ട് മസ്റ്റ് നോട്ട് ബി ലോസ്റ്റ്. വെൻ വി ഡീകമ്പോസ് the attribute must not be lost. That must be retained. That is important. Clear? This is called attribute preservation property. Clear? So this is called attribute preservation condition or condition of decomposition. Okay. Suppose example. Suppose R is having attributes A, B, C, D. It is decomposed into sub relation R1 A, B, C, R2 C, D. Okay, so here when we combine R1 and R2 together, okay, when we are combining R1 and R2 together, we are having the same set of attributes that is available in the universal relation R. That is A, B, C, D. Okay, A, B, C and C, D. So when we take the union, it is having the same attributes as the universal relation R, A, B, C, D. Okay, അതായത് എ ബി സി ഡി ഇതിൽ എ ബി സി ഡി ഇത് നമ്മൾ ഈ സബ് റിലേഷനിൽ അവൈലബിൾ ആണ്. ഇറ്റ് ഈസ് നോട്ട് ലോസ്റ്റ്. ക്ലിയർ? ദറ്റ് ഈസ് കോൾഡ് ആട്രിബ്യൂട്ട് പ്രിസർവേഷൻ പ്രോപ്പർട്ടി. ക്ലിയർ? സോ ഹിയർ R1 and R2 together contains all the attributes present in the relation R. R1 and R2 together contains all the attributes present in the relation R. Clear? So this is called attribute preservation property. It is very simple. The next property is dependency preservation property. So what do you mean by this dependency? Dependency is nothing but the functional dependency. So what is functional dependency? Functional dependency gives the relationship between the attributes. Okay. So dependency preservation property means that when we decompose a universal relation into sub-relation, the functional dependency must not be lost. Okay, that is the condition. So before going into this description, let us see this example. So let a relation R having attributes A, B, C, D, and this is having set of functional dependencies F. F is a set of functional dependencies. What are the functional dependencies? A determines B, A determines C, and C determines D. These are given. Okay, a relation. So this relation R is being decomposed into R1 and R2. Okay, so this is R1 and R2, not RR. This is R1 and R2. This is R1 and R2. So R1 is having attributes A, B, C, and it is having functional dependency F1. Okay, so this is F1. Okay, F1 having functional dependency A determines B and A determines C. And R2 is having attributes C and D. And this is having functional dependency C determine D. Okay, so this is F2. F2 is C determine D. Okay, now we will take the union of F1 union and F2. Okay, F1 union F2. F1 union F2 is actually represented as F dash. Okay, so F dash equals f dash equals f1 union f2. So what is f1 union f2? A determine B, A determine C, and C determine D. Okay, so this is f1 union f2, which is equal to f dash. Clear? Look at here. So f dash is this one. What is f? F is this one. Okay, that means that f dash is equal to f. Okay, so which means that the functional dependencies of the decomposed relation is equivalent, must be equivalent to the functional dependency of the universal relation or the main relation. Okay, so when we decompose a relation into subrelation, the functional dependency must not be lost, it must be preserved. That is the meaning. Okay, so let us now go into the explanation. So decomposition D equal to R1, R2, R3, etc. up to Rm. So what do you mean by that? The relation R is decomposed into D. So decomposed relation set is having relations R1, R2, R3, etc. up to Rm of R. Okay, is said to be dependency preservation. So this decomposition is said to be dependency preserving with respect to the set of functional dependency F. Okay, so this dependency preserving is actually explained with respect to the functional dependency F. What is the functional dependency of F? So F is nothing but the set of functional dependencies of a relation R. Okay, so when this dependency is said to be dependency preserving, if the union of the functional dependencies F on each Ri in D is equivalent to F. Okay, so union of the functional dependencies F dash, no, it is not F, it is F dash. Okay, F dash on each Ri in D is equivalent to F. Okay, so that is the explanation for dependency preservation. Okay, so by simple words we can say that the functional dependency must not be lost when we decompose a relation into subrelation. That is the meaning. Okay, so here in university we will be getting a numerical problem based on this dependency preserving, okay, or dependency preservation property. So I will give you an example for that. So the question will be like this: consider a relation R is having attributes A, B, C, D, E with the functional dependencies F. F is a set of functional dependencies of relation R. So what are the functional dependency? A determine B, B determine C, C determine D, and D determine A. Okay, and they have also said that this relation R is decomposed into, the relation is decomposed into R1 ABC. Okay, the first decomposed relation is R1 ABC and the second one is R2 CDE. Okay, so this R is being decomposed into two sub-relation R1 and R2. So check whether this decomposition is decomposing preservation or not. We need to check that whether this decomposed relation R1 and R2 is satisfying the property of decomposing preservation or not. Okay, so how to do this? Here we have to follow certain steps. Clear? Let us see what are the steps. Consider the decomposed relation separately and find out the closure of each attribute in the relation. So what we do here is we will operate on the decomposed relation separately. We will take the decomposed relation separately and we will try to find out the closure of the attributes. So we will first take R1 ABC. Okay, from that we will find out the closure of A, B, C, AB, AC and BC. Okay, so from ABC, ABC is having different sets. What are the subsets of ABC? It is A, comma B, A, B, C, then AB is one set, BC is another set, AC is another set. Okay, so we will try to find the closure of all these attributes. Similarly for this one. Okay, and after finding the closure, we will reduce the closure by using certain properties and we will try to find the functional dependencies of these relations. Okay, we'll try to find the functional dependencies of these relations. So let us go into the explanation. So this is the two subrelation R1 ABC and R2 CDE. Okay, so this is the functional dependency F equal to A determine B, B determine C, C determine D, and D determine A. Okay, so I prefer you make a tabular column, and tabular column you represent the closure corresponding to this subrelation. Okay, so here I am going to find out the closures of R1 ABC. Here I am going to compute the closures of what? CDE. Okay, the relation R2. Relation R2 attributes closure ആണ് ഇവിടെ കണ്ടുപിടിക്കുന്നത്. ഇവിടെ relation R1 attributes closure ആണ് ഇവിടെ കണ്ടുപിടിക്കുന്നത്. Okay, closure മാത്രം കണ്ടുപിടിച്ചാൽ പോലെ we also need to we need to perform certain operations such that we can reduce the closure. Okay, so let us see the details. So first, what are the sets A, B, C? So here the attributes are A, B, C. Okay, so what are the possible subsets of A, B, C? First one is A. Okay, so we'll find the closure of A. Second is B. Clear? We will find the closure. C, we will find the closure. Next is AB. Okay, so we'll find the closure of AB. Next is BC. BC. BC, we will find it out. Then it is AC. AC. So we will find the closures of all the subsets of A, B, and C. That is the first task. So we'll see how to find the closure of A. Okay, A closure. What is A closure? So we will look into this functional dependency. Okay, A closure. The first why a trivial functional dependency A closure. The first value is A itself. Okay, what will be the second value? A determine B. Okay, so B is the second value. Now next is what? Anything is starting with B? Yes, B determines C. So C is the next value. Okay, anything is starting with C? Yes, C determines A. C determines D. So D is the next value. Anything starting with D? Yes, D determine A. A is already there, so you don't have to repeat it. Clear? So the closure of A is A, B, C, D. Okay, now we need to reduce certain attributes from A, from this A closure. Okay, so what are the attributes we can remove from here? Here actually this A is actually trivial. A is actually trivial because A closure means A itself, so it is trivial. Since it is trivial, this A can be removed. Okay, so we will remove A here. Okay, we will remove A. Next is what? Next you have to check whether B, next is B, C, and D. Okay, so look at this subrelation. In the subrelation, we are having attributes A, B, and C. Okay, A is being removed. Why? Because it is trivial. Okay, now we can remove D. Now we can remove D. Why we can remove D? Because this D is not available here. R1 is having only A, B, and C attribute. D is not here. Okay, D is not applicable here. So D can be removed. Clear? So I have given the explanation also here. Here A is trivial, so it can be removed. So I have removed A. Now D is not present in the relation R1. Okay, R1 il D undo? No, R1 does not contain D, so D can also be removed. Okay, so this A and D is removed. After removal of A and D, the closure becomes A closure equal to B and C. Okay, so we will write the functional dependency for this one. So we can write the first functional dependency, which is A determine BC. Or we have written the functional dependency. A is this one, A closure. BC is the RHS. BC is the what? BC is the answer to this closure. Okay, so BC will be the RHS of the functional dependency. So A determine BC will be our first functional dependency of R1 ABC. R1 ABC എന്ന് പറയുന്ന സബ് റിലേഷൻ്റെ ഫസ്റ്റ് functional dependency ആണ് ഇത്. Okay, so next we will try the closure. We will try to find the closure of B and find the functional dependency. Okay, so B closure. We will try the B closure. First value is B. Okay, then B determines C. C determines D, yes, D determines A, so A is the final answer. Okay, so B, C, D, A. Okay, as the previous step, we can remove B here. Why we can remove B? We can remove B because B is trivial. Okay, so B is trivial, so B can be removed. Okay, now the remaining is C, D, A. Okay, look at here, this R1 contains the attribute A, B, C. We have already removed B. Okay, now why we have removed B? Because it is trivial. Next is C, D, A. Now C is there in the R1 attribute, R1 relation. D is there? No, D is not there. A is there? Yeah, A is available here. So D is not required here. Why? Why? Because D is not the part of the subrelation R1 ABC. Okay, so here the answer is B closures, the answer is C comma A. Okay, so the explanation says that B is trivial, so it can be removed. D is not in R1, so D can also be removed. Okay, so the remaining is B closure is C comma A. So the functional dependency, we can write that B determine C A. Clear? So we have derived two functional dependencies for the subrelation ABC. The first one is this one, second is this one. Okay, so when we derive the second relation, the second functional dependency, you just check that whether we have derived the similar functional dependency previously. No, previously we have derived only A determine BC. So this is not repeating. So this can be considered. ഓക്കെ, അപ്പോൾ നമ്മളൊരു ഫങ്ഷണൽ ഡിപ്പെൻഡൻസി നമ്മൾ ഡിറൈവ് ചെയ്യുമ്പോൾ പ്രീവിയസ്ലി ഇത് വന്നിട്ടുണ്ടോ എന്നുള്ളത് നമ്മൾ ചെക്ക് ചെയ്യണം. ഓക്കെ, ചെക്ക് ചെയ്യണം. ചെക്ക് ചെയ്തിട്ട് അതില്ലാന്നുണ്ടെങ്കിൽ മാത്രം അത് കൺസിഡർ ചെയ്യുക. അതർവൈസ് വി ക്യാൻ ഡിസ്കാർഡ് ഇറ്റ്. ഓക്കെ, നെക്സ്റ്റ് വൺ ഈസ് സി ക്ലോഷർ. വിൽ ഫൈൻഡ് ദ സി ക്ലോഷർ അല്ലേ. നെക്സ്റ്റ് സെറ്റ് സി ആണല്ലേ, സി ക്ലോഷർ. സി ക്ലോഷർ ദ ആൻസർ ഈസ് സി ഡി എ ബി. ഓക്കെ, ഫ്രം ദിസ് സി ക്യാൻ ബി റിമൂവ്ഡ്. Transitive dependent trivial കാരണം the C can be removed. Now D is not here. Okay, D is not required here. So the remaining is AB. Clear? So C is trivial and D is not in R1. So C and D can be removed. So C closure is AB. So the functional dependency we are getting is C determines AB. Clear? So is this C determines AB repeating? No, this is not repeating. So this can be considered. Clear? So A is over, B is over, C is over. Next set is what? AB. Okay, AB. AB closure. What is the answer for AB closure? The first value is AB itself. Okay, the remaining is what? CD. How we got CD? Because starting with A we are having B. Starting with B we are having C. Okay, so we'll write C here. Now starting with C we are having C determines D. Okay, so D can be written here. Now D determines A is given. Okay, so since A is repeating, we don't write it again here. So A, B, C, D is the answer. Okay, so now we can remove what? Since LHS and RHS is same, here AB closure is AB closure, the first value is AB itself. So since it is trivial, we can remove this AB. Okay, AB can be removed. C is actually there in the relation, as C is there in the subrelation, but D is not there. Okay, so D can also be removed. So D can also be removed. Clear? D can also be removed. So this is the explanation. Since AB is trivial and D is not in R1, AB and D can be removed. So the AB closure is C. Okay, AB closure is C. So the functional dependency here is AB determine C. Okay, so you again check that whether this functional dependency repeats. Previously it is repeating. You just check. So you can just verify whether AB determines C is there. No, AB determines C is not here. But look at here. A determine BC is here. So A determine BC. What do you mean by A determine BC? You can also write A determine BC is A determine B and A determine C. Okay, so look at here. So this AB determines C. So here we can write since we have already got, it is already written the explanation here, since we have already got A determine BC, so A determine BC can be written as A determine B or A determine C. Okay, നമുക്ക് ഇങ്ങനെ എഴുതാൻ പറ്റും. So it says that A can alone derive C. Okay, A can alone derive C. So there is not any requirement for AB determine C, because it is repeating. Why? Because A can alone is able to derive C. So AB determine C is actually repeating here. So this can be discarded. So AB determine C എന്ന് പറയുന്ന ഫംഗ്ഷൻ ഡിപ്പെൻഡൻസി ഇവിടെ വേണ്ട. This can be removed. Okay, so that is the explanation. അപ്പോൾ ഇങ്ങനെ റിപ്പീറ്റിംഗ് നോക്കുന്നത് ഇങ്ങനെയാണ്. ഓക്കെ, ഇപ്പം എ ബി ഡിറ്റർമൈൻ സി എന്ന് വരുമ്പോഴത്തേക്ക് നിങ്ങൾ ഇതുപോലെ എ ഡിറ്റർമൈൻ സിയോ അല്ലെങ്കിൽ ബി ഡിറ്റർമൈൻ സിയോ വരുന്നുണ്ടോ നോക്കുക. ഉണ്ടെന്നുണ്ടെങ്കിൽ ദിസ് ക്യാൻ ബി റിമൂവ്ഡ്. ഓക്കെ, യു ക്യാൻ ചെക്ക് ലൈക്ക് ദാറ്റ്. ക്ലിയർ? നെക്സ്റ്റ് ഈസ് വാട്ട്? നെക്സ്റ്റ് ഈസ് ബി സി അല്ലേ? ബി സി. സോ സെറ്റിൽ അടുത്ത എ ബി കഴിഞ്ഞു, നെക്സ്റ്റ് ഈസ് ബി സി. So BC closure, what is answer? BC closure is BCDA. Okay, so BC can be removed. Due to trivial property, BC can be removed, D can be removed, so A is pending. So BC determines A. Okay, so you just check whether anything like B determines A or B determines C determines A, anything like that is occurring in the previously. Look at here, B determines CA. B determines CA means it can be written as B determine A or B determine C. ഇപ്പോൾ ഇവിടെ നമുക്ക് B determine CA നമുക്ക് we can write either in B determine A or B determine C. Okay, so B can alone determine A. So we don't require BC determine A. ഓക്കെ, ഇപ്പോൾ ബി ക്യാൻ എലോൺ ഡിറ്റർമൈൻ ആയതുകൊണ്ട് വി ഡോണ്ട് റിക്വയർ ബി സി ഡിറ്റർമൈൻ എ. സോ ബി സി ഡിറ്റർമൈൻ എ ക്യാൻ ബി റിമൂവ്ഡ്. ഓക്കെ, ദിസ് ക്യാൻ ഓൾസോ ബി റിമൂവ്ഡ്. ക്ലിയർ? സോ ദ എക്സ്പ്ലനേഷൻ ഈസ് ഓൾസോ ഗിവൺ ഹിയർ. സിൻസ് വി ഹാവ് ഓൾറെഡി ഗോട്ട് ബി ഡിറ്റർമൈൻ സി എ വിച്ച് സേസ് ദാറ്റ് ബി ക്യാൻ എലോൺ ഡിറൈവ് എ. സോ ബി ഡിറ്റർമൈൻ സി എ ഈസ് റിപ്പീറ്റിംഗ് ആൻഡ് ക്യാൻ ബി ഡിസ്കാർഡഡ്. സോ ബി സി ഡിറ്റർമൈൻ എ ക്യാൻ ബി റിമൂവ്ഡ് ഓർ ഡിസ്കാർഡഡ്. ദിസ് ഈസ് നോട്ട് റിക്വയർഡ് ഹിയർ. ഓക്കെ, അപ്പോൾ ഇങ്ങനെ വരുമ്പോൾ നിങ്ങൾ നോക്കിയാൽ മതി. ഇപ്പോൾ ബി ഡിറ്റർമൈൻ എയോ സി ഡിറ്റർമൈൻ എയോ വരുന്ന ഏതെങ്കിലും ഫങ്ഷണൽ ഡിപ്പെൻഡൻസീസ് പ്രീവിയസ്ലി ഉണ്ടോ എന്ന് നോക്കുക. ഉണ്ടെന്നുണ്ടെങ്കിൽ ദാറ്റ് ക്യാൻ ബി റിമൂവ്ഡ്. ക്ലിയർ? അപ്പോൾ നമ്മൾ ഇത് കഴിഞ്ഞു, എ ബി കഴിഞ്ഞു, ബി സി കഴിഞ്ഞു. അടുത്ത എ സി ആണ് അല്ലേ? എ സി ക്ലോഷർ. സോ എ സി ക്ലോഷർ ഈസ് എ സി ബി ഡി. ദ ആൻസർ ഈസ് എ സി ബി ഡി. ഹിയർ എ സി ക്യാൻ ബി റിമൂവ്ഡ്, ഡി ക്യാൻ ബി റിമൂവ്ഡ് അല്ലേ? ഡി ക്യാൻ ബി റിമൂവ്ഡ്, ഓൺലി ബി ഈസ് പെൻഡിങ്. സോ എ സി ഡിറ്റർമൈൻസ് ബി. ഓക്കെ, ഇപ്പോൾ പ്രീവിയസ്ലി ഏതെങ്കിലും ഫങ്ഷണൽ ഡിപ്പെൻഡൻസി ഉണ്ടോ നോക്കിയേ. എ ഡിറ്റർമൈൻ ബി ഓർ സി ഡിറ്റർമൈൻ ബി ഉണ്ടോ നോക്കുക. എ ഡിറ്റർമൈൻ ബി ഓർ സി ഡിറ്റർമൈൻ ബി ഉണ്ടോ നോക്കുക. എ ഡിറ്റർമൈൻ ബി അല്ലെങ്കിൽ സി ഡിറ്റർമൈൻ ബി എവിടെയെങ്കിലും പ്രീവിയസ്ലി ഉണ്ടോ നോക്കുക. ലുക്ക് അറ്റ് ഹിയർ, സി ഡിറ്റർമൈൻ എ ബി. C determine AB means we can write C determines A or C determine B. അല്ലേ? C determine AB നെ we can write C determine A or C determine B, which means that the C can alone derive B. Okay, so we don't require AC determine B. That can be discarded because it is repeating. So this can be discarded. So this also will be discarded. AC determine B can also be discarded. Clear? So in this set of subrelation R1 ABC, we are having three functional dependencies: A determine BC, B determine CA, and C determine AB. Okay, അപ്പം റിലേഷൻ R1 ABC എന്ന് പറയുന്ന ഫങ്ഷണൽ ഡിപ്പെൻഡൻസി R1 ABC എന്ന് പറയുന്ന സബ് റിലേഷനിൽ we have derived three functional dependencies, which is A determine BC, B determine CA, and C determine AB. Okay, similarly we have to find it for the relation CDE. Okay, CDEക്ക് വേണ്ടിയിട്ട് ഇതുപോലെ നമ്മൾ functional dependencies derive ചെയ്യണം. Okay, so CDE, C plus, so I have to find the closure of C closure, D closure, E closure, then CD closure, CE closure and DE closure. Okay, ഇത്രയും കാര്യങ്ങൾ കണ്ടുപിടിക്കണം. Okay, we'll start. So C closure, the answer is CDAB. So we can remove C here. C can be removed due to trivial condition. Okay, next what we can remove, we don't require A and B here. Why? Because we don't require A B here. Why? Because AB is not here. In this sub relation we are having only attribute C D E. AB is not here, so AB can be removed. So the functional dependency is C determine D. Okay, so this is considered. Next is what? You will find D closure. D closure is DABC. Okay, so D can be removed, AB can be removed, only C is there. Okay, so D can be removed and AB can be removed. Why D is removing? Because trivial condition D is removing. A and B is not available in relation R2. So A and B is also removing. So the rest of the attribute is what? Only C is pending. So we can write the functional dependency D determine C. Okay. Next what? Next we will find E closure. What is E closure? E closure, we don't have any value for E closure. The only value is E itself. Okay, because we are not having any functional dependency starting with E. So the E closure's answer is E itself. Okay, since E is trivial, E can also be removed. So here we don't have any functional dependency. നമുക്ക് ഒരു functional dependency ഇവിടെ derive ചെയ്യാനായിട്ടില്ല. Okay, next set is what? CD closure. Okay, what is CD closure? CD closure, the answer is CDA. Okay, why? How we got CDA? CD closure, the first value is CD. Anything is starting with C here? Yeah, D is starting, so D is repeating, so we don't have to write. Anything is starting with D here? Yeah, D determine A, so A can be written here. So CDA is the answer. Okay, from while minimizing it, since CD is trivial, we can remove CD. Whether A is there here in the subrelation? A is available? No, only CDE is available, so A can also be removed here. A can also be removed. Clear? So all the attributes are here removed, so we don't have any functional dependency here. Okay, we don't have any functional dependency here. Clear? Next what? DE. Clear? Next set is DE. CD കഴിഞ്ഞു, next is DE. DE closure. So DE closure is DE ABC is the answer. So DE can be removed due to trivial condition. DE can be removed. Here A and B. Okay, A B is not here. ഇവിടെ ഏതൊക്കെയുള്ളത്? Here we have only CDE. So AB is not required, is not there in relation R2. So AB can be removed. Clear? The remaining is C. So we can write DE determines C. We are deriving a functional dependency. DE determines C. Okay. അപ്പം നമ്മൾ previously, do we have any functional dependency D determines C or E determines C ഉണ്ടോ നോക്കിയേ. Okay, in the previous derived functional dependency, you just check whether you are having any functional dependency D determines C or E determines C. ഇപ്പോൾ ഈ D determines C എവിടെ നിന്നാണ് കിട്ടിയത്? ഇവിടെ നോക്കിയേ, E determines C means we can write it as D determines C and E determines C. Okay, whether we are having anything like that? Yeah, we are having D determines C. D determines C is already repeating, so we can remove this or we can discard this one. This functional dependency can be discarded. So since we have already got D determines C, which says that D can alone derive C, so DE determines C is repeating. So D determines C means what is the meaning of that? D can alone determine C. Okay, so we don't require DE determines C. D കൊണ്ട് തന്നെ നമുക്ക് സിയെ ഡിറൈവ് ചെയ്യാൻ പറ്റും. ഓക്കെ, അപ്പോൾ DE കൊണ്ട് നമ്മൾ സിയെ ഡിറൈവ് ചെയ്യേണ്ട കാര്യമില്ല. ഇറ്റ് ക്യാൻ ബി റിമൂവ്ഡ്. ദാറ്റ് ഇസ് എ മീനിങ്. ഓക്കെ, so DE determines C can be discarded. Next set is what? So C over D over E over CD over DE over. Next is CE. Next is CE closure. CE closure. The answer is CED. Okay, here the first one is CE can be removed due to trivial, and D is only thing is D is remaining. So functional dependency is CE determines D. Okay, so since just check whether anything like C determine D or E determine D is there. Yes, we are having C determine D. We are having C determine D. C can alone determine D. So we don't require CE determine D. കാരണം സിക്ക് തന്നെ ഡിയെ ഡിറ്റർമൈൻ ചെയ്യാൻ പറ്റും, അല്ലെങ്കിൽ ഡിറൈവ് ചെയ്യാൻ പറ്റും. അതുകൊണ്ട് CE നമ്മൾ റിപ്പീറ്റ് ചെയ്ത് കൊടുക്കേണ്ട കാര്യമില്ല. CE determine D is actually useless. So it can be removed. Okay, so from this relation R2 we had only two functional dependencies, that are C determine D and D determine C. Okay, ഇതിൻ്റെ യൂണിയൻ എടുക്കുമ്പോഴത്തേക്കും we are having two functional dependencies only, C determine D and D determine C. Okay, now we combine this F1 union F2. We will take the union of F1 and F2. Okay, F1ൻ്റെയും F2ൻ്റെയും യൂണിയൻ എടുക്കുമ്പോഴത്തേക്കും we'll be getting this F1 union F2 considered as G. Okay, we'll take the union, it becomes A determine BC, B determine CA, C determine AB, next is C determine D, next is D determine C. Clear? ഇനി ഈ functional dependencies, this F1 union F2 is the derived functional dependency. We need to check that whether this derived functional dependencies is available in the functional dependency of the main relation R. അതായത് ഈ സംഭവങ്ങൾ നമ്മുടെ മെയിൻ റിലേഷൻ ആറിനകത്തുള്ള ഫങ്ഷണൽ ഡിപ്പെൻഡൻസിയിൽ ഉണ്ടോ ഇല്ലയോ എന്നുള്ളത് ചെക്ക് ചെയ്യണം. വി നീഡ് ടു ചെക്ക് വെദർ ദിസ് ഡിറൈവ്ഡ് ഫങ്ഷണൽ ഡിപ്പെൻഡൻസി ഈസ് അവൈലബിൾ ഇൻ ദ ഫങ്ഷണൽ ഡിപ്പെൻഡൻസി സെറ്റ് എഫ്. ദറ്റ് ഈസ് അവർ നെക്സ്റ്റ് ടാസ്ക്. ക്ലിയർ? ഇത് കുറച്ച് ലെങ്തിയർ സ്റ്റെപ്പുകളാണ്. ഓക്കെ, we need to check that. So we have to check whether F implies G. Okay, whether we need to check whether this F, what is F? F is this one. Okay, whether we need to check whether this F contains G. What is G? G is this one. F1 union F2 is G. Clear? So that is what we have to check. So F is this one. A determine B, B determine C, C determine G, D determine A. G is this derived one. Okay, so we need to check the functional dependencies F is available in the functional dependencies in G. So if all the functional dependencies in F is available in this G, we can say that it is dependency preserving. Otherwise it is not. That is why we are going to check that one. Okay, അത് നമ്മൾ എന്താ ചെയ്യേണ്ട? What we have to do? We need to take each and every functional dependencies of F and we need to check whether this is available in any of these functional dependencies. Okay, first we take A determine B. Okay, A determine B ഇതിലുണ്ടോ എന്ന് നോക്കിയേ. Yes, A determine B is here, because A determine BC means that it is A determine B and A determine C. Decomposition property, we have already studied that. A determine B is available here. Clear? അതാണ് സ്റ്റെപ്പിൽ എഴുതിയിട്ടുണ്ട്. സോ എ ഡിറ്റർമൈൻ ബി ഇൻ എഫ് ഈസ് പ്രസൻറ്റ് ഇൻ എ ഡിറ്റർമൈൻ ബി സി ഓഫ് ജി ആണല്ലോ. ഓക്കെ, സോ ദിസ് എ ഡിറ്റർമൈൻ ബി ഈസ് അവൈലബിൾ. ജസ്റ്റ് put a tick mark. Okay, otherwise I will just give an underline. So A determine B is available. Clear? Next one what? Next is we will take B determine C. B determine C ഇതിനുണ്ടോ എന്ന് നോക്കിക്കേ. Yes, it is available. B determine CA can be written as B determine C and B determine A. So B determine C is available here. Clear? So this is also available. Clear? അതിവിടെ എഴുതിയിട്ടുണ്ട്. B determine C in F is present in B determine CA of G. Clear? Next what? Next is C determine D. Whether C determine D is available in G here. Look here, C determine D is already available. Okay, അതുപോലെ തന്നെ ഉണ്ട്. Okay, C determine D is also available. Clear? Next is what? D determine A. D determine A available ആണോ? D determine A. Nothing is starting with D. Yes, we are having on functional dependency starting with D, but the ending is C, is not A. Okay, so D determine A is not present in G. Okay, but we need to take one more condition. If the D determine this is not available, if we find that any of the functional dependency is not available in G, we will take one more step and confirm that it is not there. Okay, what is the next step we are going to take? Next step we will take the closure of D. We will take the closure of D with respect to the functional dependency in G. അപ്പോൾ ഇതിൻ്റെ ക്ലോഷർ നമ്മൾ എടുക്കുന്ന എന്തിനു വെച്ചിട്ടാണ്? വിൽ ടേക്ക് ദ ക്ലോഷർ ഓഫ് ഡി വിത്ത് റെസ്പെക്ട് ടു ദ ഫങ്ഷണൽ ഡിപ്പെൻഡൻസി ഓർ യൂസിങ് ദിസ് ഫങ്ഷണൽ ഡിപ്പെൻഡൻസി ഓഫ് ജി, ആൻഡ് വി ചെക്ക് ദാറ്റ് വെദർ ദാറ്റ് ക്ലോഷർ കണ്ടെയ്ൻസ് ദ RHS ഓഫ് ദിസ് വൺ. അതായത് ഈ ക്ലോഷർ കിട്ടുന്ന ക്ലോഷറിൽ എ ഉണ്ടെന്നുണ്ടെങ്കിൽ വി ക്യാൻ സേ ദാറ്റ് ഇറ്റ് ഈസ് ഓൾസോ ദിസ് ഡി ഡിറ്റർമൈൻ എ ഈസ് ഓൾസോ അവൈലബിൾ ഹിയർ. ഓക്കെ, അപ്പോൾ ഡയറക്റ്റായിട്ട് നമുക്ക് കാണാൻ പറ്റിയില്ലെന്നുണ്ടെങ്കിൽ, ഓക്കെ, വിസിബിൾ രീതിയിൽ ഈ ഫങ്ഷണൽ ഡിപ്പെൻഡൻസീസ് ഇവിടെ ഇല്ലയെന്നുണ്ടെങ്കിൽ വാട്ട് വി ഡു ഈസ് വി വിൽ ടേക്ക് ദ ക്ലോഷർ. ഹിയർ വി ഫൗണ്ട് ദാറ്റ് ഡി ഡിറ്റർമൈൻ എ ഈസ് നോട്ട് ഫൗണ്ട് ഹിയർ. സോ വാട്ട് വി ഡു ഈസ് വി വിൽ ടേക്ക് ദ ക്ലോഷർ ഓഫ് ഡി വിത്ത് റെസ്പെക്ട് ടു ദിസ് ഫങ്ഷണൽ ഡിപ്പെൻഡൻസി. Okay, if the closure of D is having A as the answer, then we can say that this D determine A is also available in G. Okay, so let us look at that case. So D determine A is not present in G. In that case, we take the closure of D using the functional dependency in G. Okay, we will take the closure D closure. The first value is D alone. Okay, so we will be taking referring to the functional dependency in G, not this one, not F. But D closure കണ്ടുപിടിക്കുമ്പോഴത്തേക്കും we looking into the functional dependency of G. Okay, so D closure, the first value is D. Okay, next is what? Next is anything starting with D here. Yeah, D determines C, so C is the next answer. Okay, now anything starting with C here. Yes, C determines AB, so AB is the next answer. Okay, next anything is starting with A. Yes, A determine BC. Okay, but BC is actually B and C is already there, so it will be repeating, so we don't require that. Anything is starting with B. Yes, CA. C and A is already there, so it will be repeating, so we need not to take that. So the answer is DCAB. So whether this D closure is having the RHS of D determine A. What is RHS of D determine A? That is A. Yes, it is having A here. ഇവിടെ നമുക്ക് A ഉണ്ട്. This D closure is having A here. Okay, so since A is present in the RHS, we can say that D determine A is also available in this G. Okay, so D determine A is also available in this G. Clear? So similarly, functional dependencies G is available in functional dependency. Here it is not like that. Similarly, functional dependency in F. Okay, functional dependency is F is available in functional dependency in of G. Okay, the functional dependencies of F is available in the functional dependencies of G. Okay, if it is so, അങ്ങനെ ആയതുകൊണ്ട് we can say that here it is dependency preservation. Okay, this decomposed relation R1 and R2 is actually dependency preservation or preservation property is achieved. Okay, so this is the task. Clear? So this is a lengthier process. So we have to take each of the decomposed relation. We have to take each of the decomposed relation, and then we have to Then we have to take the subset of each of the attribute. We take the closure of the subset of each of the attribute, and we will try to derive the functional dependencies for each of the closure. Okay, if any of the functional dependencies are repeating, we will discard it. Okay, finally we will take what? We will take the union of all these, both of these functional dependencies of what? This relation 1, relation R1 and R2. Okay, the sub relationsന്റെ രണ്ടിൻ്റെയും functional dependencies union ചെയ്യുന്നു. Then we check whether the main functional dependencies is available in this derived functional dependencies. Okay, if it is available, we can say that the decomposed relation R1 and R2 is dependency preserving. Okay, this is the problem that may be asked in the university question. Okay, so please go through this problem and do one assignment question that will be I will be uploading it in the invoice. Okay.